Good morning, class. This is Mr. Roberts at Shasta High School. Today we are kicking off a kind of a different look at Chapter 4. We'll be going through this over the next 5 or 6 class days, including distance days. And one of the things I want to talk about at the very beginning of it is this idea called, it's a theorem called the Pythagorean Theorem. I think you saw it. I know that you saw it at the end of 8th grade. However, maybe not. Maybe I can't assume that you saw it as much as I think you did. But the idea is this. If I have a right triangle, so what I'm doing is I'm focusing on the triangle inside here. If I have a right triangle, and I know the sides of it, right? This is a legit right triangle with these sides. One's 3, one's 4, and this one's 5. It turns out that if I take this side and I make a square out of it. So now I'm focusing on the green area, right? The green area is not 3. The green area is 3 times 3. You see, it's 3 times 3. So this is 9. And these two sides, the ones that are green and blue, are called the legs. So I have 2 legs in this right triangle. I have a leg that's 3 long and a leg that's 4 long. I know that these are the legs because they always are attached to the right angle. So this angle right here, this little square, indicates that this is a right angle or it's got 90 degrees. The Pythagorean theorem tells me that if I take the 3 and I square it, I get 9. And if I take the 4 and I square it, I get 16. And if I add those together, I'm always going to get the same number as the third side, this thing called the hypotenuse squared, which is 5 in this case. So you can see here I'm taking the 3, I've squared it, and now watch this. If I, anytime that I do the area of a polygon, the area of a polygon is actually the area of any parallelogram is equal to the length of the base times the height, the length of the base times the height. So I can do this transformation, and when I do this, all of these have exactly the same area, right? All of those have area 9. Because I'm not changing the height. The height is measured from here to here. So all of these have an area of 9, but then I can bring this and I can bring it down into the bottom part. So I can see that part of it is this 9, right? So 3 squared is 9. Same thing happens with the 4. If I bring the 4 in, right, again, all of these have area of 16. 4 times 4 is 16. And I bring it down into it, I see that that's, they fit perfectly, right? I'm not going to call this a proof, but it's a nice demonstration of the fact that anytime you have a right triangle, leg squared, 3 squared is 9, plus the other leg squared, 4 squared is 16, it's always going to equal the hypotenuse squared, 5 squared is 25. 9 plus 16 is 25. So let's read through the math notes in this section. It's titled Right Triangles and the Pythagorean Theorem. Triangles that contain a 90-degree angle are called right triangles. So here's a beautiful right triangle. I know it's a right triangle because it contains a 90-degree angle. The 2 shortest sides of the right triangle, the sides that meet at the right angle, so the 2 shorter ones, and they're always going to be the ones that meet at the right angle, are called the legs of the triangle. And the longest side, the side opposite the right angle, is called the hypotenuse. So you can see I've got a leg, I have another leg, and then I have the hypotenuse. The Pythagorean theorem states that in a right triangle, if you take the length of one of the legs and you square it, and you add to it the length of the other leg squared, you will get exactly the hypotenuse squared. And again, we can see this perfectly here. 3 squared is 9, boop, plus 4 squared is 16, and when I add those together, right, 9 plus 16 is 25, and 5 squared is also 25, so it equals. The other thing that's true is that it doesn't have to be that particular right triangle, right? I can do any right triangle, and whenever I do this, it's always going to be the case that if I take this number, square it, plus this number squared, it's going to equal this other number squared, right? Leg squared plus the other leg squared is the hypotenuse squared. So it does not matter when we're setting this up which one we call leg number 1 and which one we call leg 2. Completely doesn't matter. It could be either one. The Pythagorean theorem can be used to determine a missing side length in a right triangle, and that's what we'll be doing. So if you look at this, in this first one we're looking at here, I can see that one of my legs is 5 centimeters I do not know this leg. It's unknown. But the hypotenuse is 10 centimeters. So what we do is we plug what we know into the Pythagorean theorem. We're plugging in one of my legs is 5 squared. Could have flipped it. I could have put this over here. The other one is x. So I square the x squared, right? So 5 squared plus x squared is the hypotenuse squared, 10 squared. Once I've got that, I go ahead and plug these in. 5 squared, 25 plus x squared equals 100. And then we're just going to say, hey, check this out. If x squared is 75, then I just take the square root of that. I take the square root of 75, and I get, rounded to 2 decimal places, I get that x is about 8.66 centimeters. The length of the missing side is root 75, or about 8.66 centimeters. The answer, root 75, is an example of an exact answer, right? While 8.66 is a decimal approximation of the answer.